Hello everyone, I'm doing a short technical review on my latest project, widths and lengths measurements on concrete cracks. Let me go ahead and show you an overview of what the application can actually do. So here I have 6 sample images, and if we select the first image and hit predict, what this will basically do is that it will use a segmentation model to segment the whole image, identifying each crack, and it will also determine its widths as well as its lengths. So let me go ahead and show you how this actually works. So here I have a dataset of 36 images, and what is very special about this dataset, and I had a very hard time trying to find such one, it has ground truth measurements, meaning the people who made this dataset, they did manual measurements of the cracks. Not all of them maybe, but they have manual measurements that I can compare my approach to be able to know whether it actually works and how good it works. Now 36 images is a very limited number, and what I basically did is I took 30 of those images to train my segmentation model, and I also used them to figure out how to measure the widths on those cracks. As for the 6 remaining images, I used them to test my approach, and I also used them to compare between my approach and the ground truth values. So if I go to ground truth grid lines here, you can basically see all of these lines, and what they are is they are the ground truth measurements at that location. If I hover over one right here, for example, you can see that ground truth width is 140 and the prediction here is 141. Here over this one you can also see it, here over this one too, and so on. How this approach actually works is it skeletonizes the prediction masks first to get a fine middle line on the crack. So I'll show you how this one looks like if I turn off the ground truth grid lines and turn on the length lines. You can see, for example, here the fine yellow line that goes along this crack right here. Now from here, what you do is you take many tangent lines along this middle line and you shoot perpendicular lines to the tangent lines in both directions, going up and down. And let me go ahead and show you how these will actually look here. So if I toggle on width lines, you can see some of the width lines right here. So this is basically a width line going all the way up to all the way down. Now that you have many width lines, all you have to do is basically calculate the mean value of the width. However, this would not really be a fair comparison against the ground truth values. So let me go ahead and zoom in on one of the cracks to show you how the comparison basically works. So let's say we have this ground truth line right here. It has a certain measurement, and what you basically compare is the width of this ground truth line, the manual measured width, with the nearest autonomous predicted width line. So if we count this ground truth line, we are only going to count the nearest width measurement that's the approach predicted. So for this line, let's say this one gets predicted. For this one right here, this one gets counted, and so on. And you can basically see a match rate here on the image that tells you 110 out of 115, which basically means that out of 115 ground truth lines, 110 had a matching predicted width line. Now here in this table you can basically see the ground truth mean compared to the approach's mean. And for example, if I select this crack, this one has a predicted width of 158 and the ground truth average is about 160. As for this one, you can see the two values right here. For this one, you can also see the values here. Now, when you don't have too many ground truth lines, it's not really going to be perfect because there could be more variation than if you had, let's say, 6 or 7 or 10 ground truth measurement values. Here you can see it more clearly. you only have 3 ground truth measurements, and the predicted width is not perfect since there's going to be more deviation without too many ground truth lines. Moving on to the next image, you can also compare the ground truth values with the predicted values, and you can, for example, let me turn on the ground truth grid lines. For example, in crack 8, it wouldn't really be fair if you only have one ground truth line compared to the predicted width. So this is not really going to be a very accurate comparison. What you want to compare is basically the cracks with many grid lines. That would be much more fair. So for example, on this one, you can see that predicted as well as the validation, the ground truth width is the same. Now, it is not really that perfect. That 56.2 compared to the 56.2 makes it look like it is just perfect. But this is not the case. You need to keep in mind that this is, I believe, the only dataset I managed to find online with ground truth measurements. You need to keep in mind that it has 36 images. We're talking about 36 images. So that is barely enough data to analyze to come up with a solution. Here, if we zoom in on the crack 4, you can basically see that the measurement here, it is 50, about 60 compared to the predicted value of 61.7. Here you can also see it is 47.6 compared to about 50 on the same grid line. Now keep in mind this is shown here just so you can compare the two values if they were to be measured right on the grid line, if the prediction was to be measured on the grid line. But this is, as I said, not really used in the table. So you can see here that the values really deviate from each other, and they are not exactly the same as the table suggests. And this is basically just because the mean happened to be exactly the same as the mean of the ground truth value. On this crack right here, you can also see it's a good value. Now moving on to such an image, let me go ahead and hit predict. In this image, you can see for the big crack, you can see the ground truth value, and now you can compare these two basically. You can see that there is more of a difference than in the last image. You can also see it in this crack right here. Let me turn on the ground truth lines. It is two ground truth lines, so I wouldn't really say it is very reliable. What is very interesting about measuring the crack width is such an area right here. What is interesting is that what would you define as a crack? Because you can see here in this area that this is maybe a partial crack, but I'm not really sure if you would define this as a crack or not. So you can see there are too many small subtleties, too many small things that you need to take into account. What would you consider a crack? And when training the segmentation model, you also have to, of course, account for all of these things. Now in this table, you can also see other cracks with the width, predicted width, as well as the lengths. This right here is not really that much visible, but basically if the dataset did not include any ground truth measurement for a crack, then only the predicted widths and the predicted lengths will show in the table, and not really any ground truth validation. One of the other things that I did not mention yet is that depending on the widths, on the predicted widths, you will basically be able to tell if you need to do something about the crack or you can just leave it alone. So here you can see, depending on the measurement, how many hairline cracks there are, how many fine there are, moderate or severe. And actually, let me go ahead and go back here to this image, shows a prediction overlay. So one of the other things is that not only whether you would assume this one right here is a crack or not, but it's also depending on that, and depending on what you are looking at, depending on what kind of cracks you are looking at, you can see right here that this is considered, for example, fine with the predicted width. But if you were to consider this area as a width, as a crack, then the crack would not really all be the same. If we were to consider this area as cracking, it would be severe here and maybe fine in other areas. So that also depends on what kind of data you're looking at, or what kind of structures, what kind of cracks you are working with, and what you specifically need. Coming back to this image, you can see the ground truth values. Let me show you the ground truth grid lines. You can see the ground truth validation compared to the predicted values, which is, I would say, not bad at all. Now here in this image, you can also compare the crack too. You can also compare this crack, the ground truth measurements, to the predicted measurement. Let me show you the ground truth grid lines. For crack 3, I wouldn't really say it's a fair comparison, since you can see here there's only one grid line, one ground truth grid line. As for this one, this would definitely be fair. It looks uniform enough, and you can see that there is about 12 micrometer difference in the prediction. Now here's the last image, and let me show you the ground truth grid lines. So you can basically see here that the ground truth measurement and the predicted measurement, they do have quite some difference compared to the other images. Right here you can also see in this crack specifically, I think this is the worst one of them, with a difference of about 40 basically, 40 micrometers. There is definitely more work to be done, but it needs more data. Let me know what you think, and if you have any data set with ground truth measurements, and you wouldn't mind sharing, of course, please do not hesitate to contact me. I would love to test my approach on other images, but as I said, I was only able to find this single data set with ground truth measurements. Thank you for watching.